Hi there. Let's look at problem 102. Binary 3-level order traversal. Given the root of a binary 3, return the level order traversal of its nodes value, i.e. from left to right, level by level. Okay, so we're given V3 root, return level order traversal. And level order traversal is from left to right. Okay. I think the problem is quite clear that we just want to print out the level order traversal. Unfortunately, I'm not sure what left to right means. So let's look at the examples there. We have 3, the left side is 9, right side is 20, left side is 15, right side is 7. So the output here, it says, first of all, we print 3, and then there is 9, 20, and then 15, 17. Okay, let's look at the second example. We have 1, and then there's just 1. Third example is empty, then we print out empty. So I think I kind of understand the problem now. So we are printing the current node, and then the next level. I see. So that's why it's called level order traversal, because we print it level by level. I think I missed that point. It was pointed out before. Yeah. So it is actually just printing level by level from left to right. Okay, so I think I understand the problem. May I clarify a few questions? First one is, I think there is not much to clarify here, because we already see that there is a empty example as a test case. So let's just move on the next step, which is I'm gonna think of some way, which is we will need to come up with an approach to solve this problem. The way I see this problem is actually quite straightforward, because we just it's an level order traversal, meaning that we can we are given the root. So the first step is we print out the root, and then the next step we print the next level, which is the left side and the right side. So what we can do here, let me write down the step. We can use So we can use the queue. We start with the root. Then queue. So the queue here represents the current level nodes. So the second step is empty the queue while printing. So we look through the list, which is all the nodes in the current level, and then we print it out. But at the same time, and save the chart, and then we queue in the chart. So here we will need two loops. First one is checking if the queue is not empty, and the next step, and the inner loop will go through all of the elements and then create the output. Does this sound reasonable to you? I'd like to start implementing this unless you would like me to explore further optimizations. Okay, so let's start coding. First of all, I will need to, there is something called dequeue in Python. So let me just quickly check it. So dequeue we can use append and pop left. Alright, so that's pretty obvious what we need to do here. So what you're gonna do is we create, I'm gonna call it level, and then initialize it into starting with root. I'm not quite sure the API usage is correct, but we will find out later when we run it on LeetCode. Then what we're gonna do is, hold on a second. Okay, so the output there, I'm gonna call it Traversal, initialize to empty list. Then I'm gonna while level. So we're gonna keep checking whether level is empty. If it's not, then we need to print out those values. So while level, then we're gonna do say for we don't need to save it. I in range of length of level. What do we call it? So okay, let's just start it inside the node variable level.pop. And okay, so we need to create another list to store in our output. Now cur.append node.file. Then we need to check if there is a child there. So if node.left, then we append it into the queue. And then we do the same on the right side. And the ordering is important here. So we need to append the left child, then the right one. Otherwise, it is not left to right ordering. Okay. After the loop finishes, we append the output into our final solution, which is traversal. So traversal dot append curve. Okay. Then at the end we return the output. Alright. Let me quickly go through the code again to make sure I haven't missed anything. So here I'm gonna use dequeue initialize to the root. Okay, I guess I also need to check if the root is empty. So instead of directly inputting the root into the dequeue, I'm gonna check if it is null. So if I think it's better to just initialize the queue first, and then inside I'm gonna check in another line if root, then level.append root. Okay, and then I also have another variable there where I'm gonna store the final result. So in the second part, in this part, I'm gonna look through the level, I mean all the nodes in the level, and then bring up the value, and at the same time I'm gonna append the children from left to right. Once we exit the loop, it means that we have completed the current level, and it's time to move on to the next level. Before doing so, we append the solution to our final solution, and then at the end, when level is empty, it means we completed, so we can return the solution. Now it's time to test the code with our examples to make sure it works as intended. The first one, we append 3. So let me just write here. Well is 3, and then traversal be what is it? It will be 3, and then the children of 3 is 9 and 20. Actually, the traversal and level are the same, so let's do it twice. Then 9 and 20. 9 has no children, but 20 have 15 and 7. So yeah, that's what we got. Second one we have is just one. That would be our output. Third example is empty, so the output is also an empty list. Now let me put our solution into LeetCode to make sure it works. So level equals dq deck. I think it's called deck. And then we create level.can. So now we need another variable for our solution. Initialize to empty. Then while level curl equals empty. For looping to the element in the current level, net equals level.edit. What we need is pop left. Okay. Then curl.append level.form. Then we check if the children is valid. Then we append. I think in Python there is something called walrus, so let me try that out. Actually, let's just do it in a normal way. I think it's not cleaner that way. So level.append no.left, and don't forget about the right chart. Yep. Then once we finish, we append the curve to our final solution, and then we return it. Yep, let's try to run it. Hopefully it works. Well, actually no, so it's not level, but it's the node. Alright, let's try to submit it. Hopefully we got it right. And yes, we got it right. So I hope this helps. Let's look at some other solutions then. We don't need to do so because people are mostly doing more or less the same. Yeah. Alright then, let's stop here. Thank you everyone.